a brief history. The history of modularity in computer systems is quite long, in fact. In fact, it's like 45 years since first paper decomposing systems into modules was published. But let's fast forward to Java world. So in year 2000, OSGi was created. That was an alliance with an aim to modularize Java. And in 2006, the first JSR appeared with the aim. All well and good, but 5 years after that, Java9 appeared, no modularity inside. 3 years ago, Java8 appeared, still no modularity, right? So something didn't go too well. Meanwhile, I was on 2 conferences that changed my view of the world and how should we architect systems. One is 33rd degree, that's today it's DevOps Poland, that the talk was Java, the Unix way, how to build microservices. The other conference was in 2013, it was Booster Conf in Bergen, I highly recommend it. And the talk was called Developers Anarchy. It was by Fred George, and he was talking about totally independent teams of small teams of hackers deploying services, just whatever, writing code in whatever language they want and deploy them independently. So that was really inspiring. That was one of the few, I don't know, wow moments of the conference that happened on the conference. And as we fast forward to 2017, we have totally different landscape, right? We have plethora of platform systems for deploying microservices. Each conference can get away with track or at least 4 or 5 talks on microservices. You have Spring Boot, that's covered here. You have Scala Legume, Docker, Hystrix, Fabricate, Kubernetes, Mesos, and many other things that I won't even talk about. So the future looks pretty beautiful, sorry. You take your monolithic application written, for example, in Spring, and you divide it into separate small applications. You deploy them with Spring Clouds, Spring Foundry, or whatever do you want, or Mesos Kubernetes, and life is beautiful. Well, almost, and sometimes, but you should never forget about Martin Fowler's advice that just like on a roller coaster in Tivoli, you have to be that high to enter. You have to have some baseline competencies that you have to have if you want to deploy microservices architecture. And if you don't, certain bad things may happen. So the first story was from my technical interview that I had with some young guy who was working at the time as an architect in some, well, early stage startup. They had only 2 or 3 developers, but nevertheless, they pursued microservice architecture. They had like 5 or 7 independent services, 5 or 7 independent JVMs. They had, of course, polyglot persistence for database types like Postgres, Redis, Mongo, and something like that. And the architecture seems pretty reasonable until I asked, so how many concurrent users do you have? Well, about 100 daily. So, is your business happy with our architecture? No, that's why I'm leaving. They're moaning about overhead and complexity and so on, and that they don't want us to pursue our real architecture. Okay. In fact, we didn't hire him. And the second case is from PayPal. That company can be described as anything but small. And recently I found a blog when they were saying that they moved their services, formerly deployed as microservices, to just 8 VMs, processing millions of transactions per second, right? In fact, they are employing some custom-made Scala, ACA, or something like that based system. But the case is that they put most of their services in just a few VMs to achieve greater performance. And the last case is the most interesting case for me, because this is my case. So we're a small software house, and we are working for, we're not a startup, we're working for external clients in enterprises. So we're working with their IT teams. They don't code, they prepare requirements, they try to plan releases and so on. And they also have operations team. Because they are big enterprises, they are fairly conservative. So if you look at that, you don't see a place for microservices deployment, when you have vertical slices, or on this picture that would be horizontal, sorry, but slices through all this stuff from code, through deployment, up to operations. You can make this chasm disappear, but this one won't disappear, because we are separate companies, and we will remain like that. We're not one team, as two teams. And that should be reflected in our architecture. This is what Conway's law is saying, right? So this is probably not the best place to try the microservices classical architecture. But why do we even consider that? Why do we want to pursue microservice architecture? And the reason is we want to have modular decoupled systems. What does it mean? It means basically that when you have different pieces of our software talking to each other in some way, let's not try to specify which way is it, and one of the pieces will disappear, will break, will change. We don't want the other pieces to also to break, or we don't want to have to deploy new versions of them. So coupling can occur on many different levels. The first one is on the code level, where we have tangled mess of packages. The second one is at the build level, if we have to put everything into one single jar. The third place is deployment. If we have to deploy all our services concurrently, then it surely leads to some intangible mess of release management processes. And also there's also runtime coupling, right? If one service breaks or has problems, then all the other stuff will break simultaneously. Okay? Just as we have different coupling levels, we have also different ways of fighting coupling. So the first one is fighting coupling on the code level. We divide our code into nice packages or to Maven modules, but then we put them into one jar file or war file or whatever and deploy them just as a big piece of software or big ball of math, whatever we want. And there's another way. That is, we still divide our code into packages or modules, but we deploy them separately. This is the classical microservice architecture in separate JVM processes, right? And this is much more decoupled way of that. But we still have runtime coupling. Even if our services are in different JVM processes, then we can still have temporal coupling due to incompatible API or transactional stuff. And it doesn't depend how we deploy the system. It depends how they talk to each other. Through REST API, RMI, God forbid, or some event messaging stuff. Then it's slightly better. So maybe, just maybe, we can stop somewhere in the middle. On the one side, we have splitting our code only on the code level and put inside just one package and deploy it together. On the other side of the spectrum, we have microservice deployment. When we deploy each service separately in different operating system processes, and we also deploy some cross-cutting functionalities separately. But maybe there's some middle ground where we still have modules, we still have different packaging of different modules, but then we deploy it as one JVM process, right? Because we're on the JVM, right? I'm JVM developer, maybe not Java developer, because I develop quite a lot of Scala code, but JVM is a VM. We can do better. Not only deploy one fat jar with flat class file. So as I was saying, there are two main efforts with the aim of modularizing Java. One is OSGi, this is the older one. It's led by OSGi. Alliance is quite an independent organization led by IBM and some other parties. Liferay is also a vital part of that. And their first release of specifications was made like 17 years ago, quite a long time ago. And the last one, release 6, was just 2 years ago. Meanwhile, there's Project JIX with the aim of modularizing JDK itself. This is a pretty noble goal. And there's JSR 376 that describes that, and it should be released pretty soon. But Both of these approaches have some problems. This is the main problem with OSGi. It has really, really bad fame. This is not a tweet from a random Java guy. Mario Fusco he's a Java champion. He's a smart guy. So there has to be something in it. And you see, people like that. And this is a common approach to OSGi development. Don't tell me about it. But, well, let's see. With Jigsaw and Java modules, the problem is a bit different, right? The first release date was 2010. It should be in Java 7. Then, in 2014, Java 8, right? Did we see that? No, not exactly. Then it should be in 2016 with Java 9. Are you using Java 9? Not anybody? Okay. This year it will be really, really released. Although, when I was preparing the slides, I was hoping it will be released in like 2 weeks. But it was postponed by further 2 months. So it's like waiting for God. Well, we'll see if Java modules will appear or not. But you may think, so how can this happen, right? There are bright guys, smart guys in OSGi Alliance and both in JDK. Why can't they put this module system together? And I believe that the reason is that it's difficult. Because just like you have Agile, right? If you listen to this Agile proponents, they'll say, Agile won't solve your problems. It will make the problems visible, your organizational problems, but you have to deal with them by yourself. And it's the same with OSGi. OSGi will also make your design problems visible. And not only OSGi, but modularity, in fact. All modularity frameworks will expose your problems with design. If you didn't design your system in a modular way, it will hurt you. It will be hard to use. So, what I want you to ask is to leave your prejudice, if you have one, for, well, about 30 minutes. And I'll tell you what I'll have to tell, and then you can leave to your views on OSGi and stuff like that. So, let's go to the world when everything is not an object. Of course, inside everything is an object, but also when everything is a module. But you may ask, what is a module, both in OSGi and with Jigsaw Java9 world? And it's pretty simple. And module is just a bunch of code put into a jar, where else can you put code, together with some metadata. In Java9, this metadata is put into some brand new file called module info Java, while in OSGi it's put into good old manifest file. And why would you put this metadata in those files? Well, to be able to describe how do modules communicate with each other. What parts of the functionalities, what parts of the code are exposed, and what are private. What does your module need to be working properly? Just more or less like Malan described in the morning. Okay? So how does this manifest file look like? In fact, it's not so difficult. It's pretty simple. This is how module info, at least in simple version, looks like in Java9, right? We define my module has a name. Why not? It requires another module to be functioning properly, and it exposes some packages. Other modules will be able only to access this package from a module, and it's the job of Java module system to prevent them from accessing our packages, for example, containing implementation. And in OSGi, it looks a bit similar, although maybe a little bit intimidating, because I also declare that my module exports this functionality, but here are some other strange-looking options, in particular, what version of the module of the package is exported. And when I import package, I also say, okay, I want to use Java's WSRS, but with specific version range. Here, it's much simpler, so probably people will be more keen to use that. But this one's here and this not yet. Okay, now that we know what a module is technically, maybe we should ask what should be a module. How large should it be? Should we put whole of our project into one module? Probably not. Then we'll stick with the monolith. If we put every package in this into separate module, we can do it, right? The package is the smallest granularity that we can achieve with both modular systems, but then we'll end up with intangible mess. Maybe a layer. If you look at some of the older OSGi tutorials, you'll see that they advise to divide your code into layers, but that's not what we want to achieve, because then what you end up with? Free-tier application, right? We don't want that. We want services, just like in microservices. So how do we deal with that? Well, if you look at the microservice architecture, it would look more or less, if you think about microservices based, for example, on Spring Boot, it would look more or less like this. You have one microservice, here you have your business code, some libraries, all of that's put in the fat jar, and they communicate through some kind of API. It's usually implicit. It can be REST contract, the WSDL, some XSD schema, or just, God forbid, Swagger documentation. So we'll do similar thing, but in one OSGi container, right? We'll have one module with API, and that won't depend on anything, just simple data description, for example, Java beans or Scala case classes. We have a module with our implementation, our business logic, that won't expose anything but the API, and we have some libraries that we throw into. So these things look pretty similar. The only difference is how we deploy stuff, and that here the contract is explicit. Sometimes we need to cheat a little bit, and in fact to embed one or more libraries into this module, because they don't play too well with each other. It's cheating. We usually do it using Maven Shade plugin, but sometimes it's needed, because many of the libraries out there that you want to use are not modular. They are very difficult to use in modular environment, and sometimes you want to put into one container two libraries with different versions. Versioning is really, I think, the most difficult case with all these modularity platforms, because let's assume this is our container, and we deployed modules like order version 1.1, user module 1.2, user 1.3, user 2.1. Everything is inside our container. So which version should we use? In OSGi, they employ semantic versioning. If you've heard about semantic versioning? Yeah, more or less. Okay, so for those of you who don't know, the idea is that we split the version into three parts. One is major version that describes non-compatible changes. Second is minor version that describes compatible changes. And the last one is micro version, that's just for bug fixes. So when we decide that our, for example, I don't know, order service needs to use user module, we declare in OSGi that it wants to use it in versions. We want to use the version range starting from 1.2 to 2.0, excluding 2.0 because 2.0 means the change is incompatible. And it's up to OSGi container to decide that, okay, this version is too old, this is too new, these two can be worked with. And it will choose appropriate version and resolve all the classes properly. Unfortunately, it's not so easy sometimes when you have longer dependency chains, just like here when A depends on B and C depends on D in that version and B depends on D in that version. The OSGi container has a hard job and sometimes it fails. Because in fact, sometimes it's not possible to adjust the versions because this module A have to have kind of consistent view of the classes it sees. And everything is based on normal Java class loaders, so it's not possible that this module A sees two classes, one from here and one from this module. So this leads to errors like that. That was I think it's one of the main reasons of OSGi bad fame. This is my exception from my code, so they are really difficult to resolve. Yeah, and this is one of the parts why OSGi is hard. So let's see, maybe. Yeah, that's true. That's true. So let's see how Java9 deals with the situation. It deals pretty well, I'll say, in an elegant way. It says it's not the goal of the module system to solve version selection problem, which is best left to build tools and container applications, which means that it's only permitted to have one version in your Java9 modular application of the module. There's no such thing as versioning Java9 modules. Or maybe in 2 months it will appear. But so far, that's the way. So we move the problem to Maven, Gradle, and stuff like that to resolve our versioning problems, which is not so bad idea, because then you can move solving of problems not to runtime but to build or compile time, which is kind of a good thing. So versioning is hard, and it's also hard in normal microservices architectures, right? I mean, REST APIs can hide most of the problems, but they are still underneath. They just bite you a little bit late. But anyway, to sum up this part of the talk, modules give us nice and explicit contracts and make it more easy to refactor and standardize on same versions of libraries, and to make it easier to refactor code, just because we deal not with some REST APIs, but with normal Java APIs. But it's more difficult to have different version of some particular library deployed into the same container. But that was the part about the code. But the service is not only the code. If we had a module only with code, that would be the library. And service is also not only code, but also the behavior. And by behavior, I mean configuration, handling lifecycle, and also discovery. Right? So in your normal CDI or Spring applications, you will solve it like this. Of course, with annotations, right? This annotation singleton is for dependency injection, one could say discovery. This is for handling configuration, and this is for handling lifecycle. Since we're in a fat-jar environment, we just start it and then stop it, and lifecycle is pretty simple. Most of our things are singletons, so yeah, we're pretty object-oriented, right? So, how does our modular platform solve this problem? What mechanisms they provide? We'll start with Java9 because it's simpler. Well, essentially, in your module declaration, you can say that this module provides some interface with concrete implementation. And then in another module, you can say, okay, for this module to be able to work, it needs to be provided with user service, right? And at the moment of starting your Java9 application, the system can say if all these requirements are satisfied. And then inside your code, you would use your good old service loader that Milan talked about sometime before. So, in fact, this is kind of, I would say, really simple mechanism, even simplistic, because it provides you only with some static wiring, static methods of declaring your services. You cannot base services that you provide on configuration or handle any dynamic situations. But in some cases, it may be enough. But I would say that service loader is not, it's kind of 90s, right? And we're about 20 years ahead. So let's look how OSGi handles all those services, dependency injections, and so on. In fact, more than 7 years ago, Peter Krins, that's one of the leader, I would say, members of OSGi, said that he wants to promote the idea of microservices, but written in Mu, as design primitive. So in fact, it's OSGi that invented the term microservices. Remember about that. So how does it work? Well, in each OSGi container that you start and install your modules into, you have a service registry. And each module that is installed and started can register a specific object with its interfaces in this registry, also with some properties, like name, like version, and stuff like that. And the other module of a bundle, as we said in OSGi, can track services of certain interface and with certain properties. This is kind of an LDAP filtering, and the OSGi container will provide it with instances, if they exist. Okay, so I'll save you the gory details of low-level API, because it's really low-level stuff, and it was written like, I think like 15 years ago, when the Java version was, I think, 1.3 or 1.2, so it was really a long time ago. But the good news is that with certain tooling and libraries, you can achieve more or less the same situation as you have with Spring and CDI. That is work with annotations. That's stuff we all like. So it looks like normal Spring application. You have singleton interface, you have inject annotation. The only difference is that in some cases you would provide this annotation, OSGi service provider or OSGi service. What do they mean? In fact, what they provide us with is the method of separation of context. Because if you have a large Spring application, probably consisting of a few jars, then you end up with a large bag of beans. Everything is accessible by anything. But here, the modularity lets you make some of your beans, let's call it that, private to your bundle, private to your one module, and you can declare that only some of them, that's annotated with OSGi service provided, will be accessible to our modules through OSGi registry. So I think this is pretty interesting and powerful context that you can achieve this separation not only on the level of code of the packages, but also on the level of certain services, that you can have some of the beans private to your module and some of them only exposed. It can get even better because there's additional specification called distributed OSGi that lets you connect OSGi containers together. In fact, it's not so difficult because each of the containers have their own registry, and we can connect them together with some kind of stuff like zookeeper, etcd, and so on. That's just implementation detail. And then you can declare that some of the services in your one container can be accessible to other containers, right? Through some means of discovery. But from the point of view of the services, it's not too different than the discovery that happens inside one container. The fact that it's in different containers is somewhat hidden from you. Of course, this situation introduces another level of complexity and another layer of problems, because here the situation can be pretty dynamic, right? You have one container and second container, and this can get restarted, it can disappear, it can be replaced by other one. What should happen with services here? And it turns out that there are annotations for that. In your normal CDI application, you would have just simple stuff like post-construct, pre-destroy, and stuff like that. And here, in some OSGi service dependency injection frameworks, you would have additional annotations like activated, updated, that you would decorate methods that should be invoked, like for example, one dependency of your service disappears or appears and stuff like that. But it's not so easy to handle. Again, this is not just a random Java guy. This is James Strahan, if you know, that's the guy who invented Groovy, Apache Camel, and similar stuff. So they try to But a platform that I was using that did many interesting and advanced things with OSGi services, and they gave up because it's hard to avoid mistakes in the logic of restarting and updating the dynamically services. And why is that? Well, the main reason is that this method stop on thread is deprecated. And if you look at the comments in Javadoc, it says that you cannot reliably stop a JVM thread, reliably meaning releasing all the logs, all the resources that it possesses, right? The only way to kill Java thread is to kill JVM. And that's why dealing with hot deployment stuff is pretty difficult, and most cases should be avoided, right? If you can make your bundles, your services work, be wired together in a static way on the build level, not on the runtime level, you should try to do it. But there are still some mechanisms that enable you to do it dynamically. Okay, so that was. These are the, I would say, benefits and pitfalls of services, OSGi services over microservices. So we have well-defined contract and separation between the public part and the private part. We have nice dynamic resolution, especially in OSGi, that will let you distribute things only when needed. For example, when for performance reasons you want to move some of your services to the different JVM to achieve better performance. But because most of the time it sit in one JVM, the separation is pretty weak. And you have to be prepared that if one service misbehaves, you have to restart the whole JVM, right? So if you have a case when you cannot just restart your JVM machine due to some SLA constraints, then probably all these microservices in OSGi stuff may be a little bit more problematic for you. But at this point, you may wonder, okay, so this is some theoretical stuff, there's some APIs, but does it have something like Spring Boot that will just enable me to use this in a real project? Not just some tutorial, not just some calculators, but my real enterprise services. And the answer is, it's not that bad. Let's look at the ecosystem. So on the bottom layer, we have Apache Felix, that is OSGi containers, and various APIs provided by OSGi and Alliance, right? This is more or less like almost on the level of JVM. Then you have a very interesting project called Apache eclarative. If you haven't heard of it, does anybody heard of it? Yeah, few people heard. So if you haven't, you should check it out. It's kind of micro container based on OSGi that provides you with various goodies like custom shell, methods of provisioning, of monitoring, of starting and stopping custom instances, and so on. And on the top of that, we have another set of projects. One is Apache Ares, and another one is, it's not easily visible, it's called Observer.j, and they provide some small but useful libraries that enable you to use, well, normal JE stuff in OSGi deployments. That's JTA, JPA, stuff like that. You can use most of them pretty easily in all in all the applications written for this platform. So the frameworks and the libraries are here, although they are developed maybe a little bit slower than, for example, Spring stuff. But what is, I would say, unique proposition of this platform is the ability to build your containers with some declarative configuration. Just like you have Lego bricks, that would be all modules, each brick would be a module, and you have instruction how to build stuff. I think the Lego should appear on conference in Denmark, so I've put it here. So how do these profiles look like? they look more or less like this. So you have kind of properties files that describe how your containers should be built with. So the profiles form some hierarchy, so we have some parents, and here we have some URLs describing where our modules are located. So here we say, okay, this profile consists of stuff that is in its parent profiles, and the bundle, the module with API, and the module with implementation. And also in profiles, we can have kind of normal configuration, business configuration that will be injected in our services. The good thing is that the profiles for some hierarchical structure with, I would say, multi-inheritance. So we can easily define on the level of configuration that we want to build one OSGi container with user service and some base functionalities, and another container consisting of order service and basket service, again based on some common functionalities. And if we want to move this service to this JVM, for example, for some performance reason, we just change the configuration. We don't have to change the code. Okay? So that can be integrated quite nicely in your normal CI or continuous integration or continuous deployment pipeline. For example, we keep our profile files in Git or our version control system, and we can let Jenkins build our containers and deploy to various virtual machines. This can be done with Ansible or anything like that, and through that we achieve that our infrastructure is described as some kind of configuration that could be easily versioned, audited, and so on. So now I'll show you how it looks like in practice. How many time do we have? We still have a few more minutes. So what I prepared was some two simple services. One is user API. It has some database of the users, and the other is offer service that loads users from the database and prepares some best offer to buy some books. Let's see how the code looks like. So in user API, it's fairly simple. We declare some data class. These are some just Lombok annotations or JDK annotations, nothing to worry about. This is normal Java class, and this is normal JS service, right? All the common annotations. There's nothing to worry here about. I don't cheat. There are no OSGi annotations or anything like that. That's just normal Java interfaces. And here we have horrifying file called BND, where we declare which of the packages are exported. So here we export the contents. And we build the stuff just like a normal jar. If you look at the POM, there's also nothing to be worried about, except one innocent plugin. So how does the service that provides us with this API look like? Again, here, nothing particular terrifying, just some persistent declarations that can be, at this point, auto-generated. And inside, okay, we have some Hibernate stuff, and we have normal service that you would writing just CDI application. Here we have a notation transactional, singleton, again, nothing to be worried about. And here only we use OSGi annotation. Here we say that this service should be accessible to the other bundles, and here we are defining some metadata. Here we are saying that this should be accessible to other containers through distributed OSGi, and here we declare how should it be done. Mainly it should be exposed as REST interface. And here, again, nothing to worry about. We inject persistent context and so on and so forth, right? And here we have normal persistent API. Here, the only interesting part is that we don't use normal JNDI that we would use in J container, but we declare that we want to use data source that would be OSGi service named user. but it's just an URL, right? So there's API, there's service. Now let's see who consumes the service. This time I used not the common CDI annotations, but this time I used something called declarative services that Milan also used in his presentation. That's some dependency injection framework that's part of OSGi specification. So, but again, it's nothing to worry about. Here I declare that this class should be a component, just like singleton, right? And it should expose offer service to the Java bundles, and it should be configured with a configuration file pl mproc offer configuration and some additional properties that it exports. And here what happens? Well, I have reference annotation, which means just more or less inject, right? This is my dependency of the user service. I have some method like getBestOffer. Again, it's exposed as normal REST API. And the only interesting part, more or less, is that I have start method that would be invoked each time the service is activated, turned on, and also when something is modified. In this case, when my configuration, which is again described as some configuration class, which means when the configurations change. OSGi, and in eclarative in particular, lets you handle changes of configuration dynamically, just as new version of Spring lets you with Spring config server, I think. Okay, so we build this whole thing, just like that. Maybe an install, it builds, and something is getting created. Something called assembly is getting created, which more or less amounts to kind of a fat jar with some additional start scripts. So what gets created is described here in a module called registry, and this is in fact the repository of our profiles. This is what I would put in some separate Git repository, and that would be used by Jenkins to generate our binary packages. And here I describe the profiles. So I have some base profiles with some base configuration files. There are some dragons in there, so I won't show everything of it to you, but once we define the base, we can define user profile, and it says, okay, if you want to build assembly user, you have to put service user profile inside, and here I declare, okay, I want to use JPA, I want to use Hibernate, I want to inherit from some of my base profiles, and I want to put in this OSGi containers those two bundles, right? User API, user implementation. And for offer, it's more or less similar. I want to have user API, which I use, and also the offer implementation. And inside, I want to have some configuration file. That's my business configuration that will be injected into my service. It's not that bad. And then the Maven builds me a charav binary. I have one binary with just user, one binary with offer services, and one binary consisting of both the services. So now I can run just user service. No, not less. And now comes the one moment. Do you see that? Just like in Spring Boot. Just like Spring Boot, I can have ASCII art. So that's great. And here I have charav shell. This is kind of more or less almost like bash shell. I can even SSH to it from some remote containers. I can see all the packages, what's happening inside. I have many interesting goodies. For example, I can query some data sources that I defined from user, and it queries something because here in my DB profile, I declared that I want to have database data source named user, here is the configuration, h2, some initialization scripts, and so on. So it got deployed into this container. So it works, and it exposes this REST API, right? It works. And then I can, so this is my first container with user service this time, and I can start also the second container with the offer service, which communicates with this one, right? This is assembly user, this is assembly offer, and I have to remember what was the exact address of the second interface. I hope it was something like that. Okay, so the second interface also works, and we'll see in a moment how OSGi handles the dynamic nature of those services, because here I kill the user service, and what happens here is that I see that the module with offer implementation is in status waiting, and it doesn't expose the service anymore, right? Because it doesn't have all the required services. And now, when I start the assembly user again, it will be, in a moment, should be on again, right? So, and it works again. So this is how distributed OSGi works. I could also build our profile, this time with both of the services at the same time, right? It inherits both from user and offer. Assembly both being scarf. And then I would have all of my modules together in one place. Better for some kind of, I don't know, integration testing or stuff like that. Okay. Starting or as you can see, as usually on demo time, something got locked. Probably my H2 base got locked, but nevertheless we can see how it's configured by this profile mechanism. Okay, let's go back to the presentation. So, if we were again to answer the question, does it have Spring Boot? Well, sort of, right? I mean, for me, OSGi and Java platforms has really impressive set of features. It's a really great thing to be able to separate the code, my bundles, from how they are deployed. But nevertheless, the community is small. There's no such company as Pivotal who would take care of everything. And also the support of the IDE and the documentation is not so great. So there are some problems. I would say it can be described as work in progress, but hey, it's open source, so you can contribute. All contributions are really welcome. So if you ask me if all this stuff works in production, well, for me it works. We have quite large integration platforms with 4 vendors of bundles, more than 200, I think, bundles of profiles deployed on more than 80 containers on 14 hosts, right? So yeah, it's production ready, and even our client, that's large Polish telco, said that, okay, they were on Microservices workshop based on all the Spring Boots and our goodies, and they say afterwards, okay, but we can do most of the stuff on our OSGi platform. So yeah, that was when I felt kind of proud, although there are a lot of problems with that. But with your normal, I would say normal microservices deployments, you will also have them. Okay, so if you ask me, do you need modularity in Java? Yes, you need, at least sometimes. For example, if you scale for performers, then maybe microservices are a way to go. If you scale for code complexity or code base, then maybe you can look at JVM modules. If you have profit per DevOps, then microservices might be the way to go. If not, then you'd better look at JVM modules. If you want more static configuration, more simple resolved at the build time, then maybe, why not, look at Java9. If you want to have dynamic stuff and all these distributed OSGi goodies, then go to OSGi. And if you wait 2-3 more years, when things will settle down, okay, you can wait for Java9. If not, maybe, just maybe you can consider OSGi. But this is the most important slide, and this is the last one for today, that I believe you can achieve most of the benefits of decoupled on a single JVM. You don't have to spin all those containers in Dockers. You can, but you can still stay on single JVM. Thank you very much. You can contact me more or less like this. And if you have any questions, then I'm still here. That's a great question, and I think it still remains an open question because there are some rough edges around Jigsaw, I believe, that I don't know if you know, but around a month ago, some voting on Jigsaw draft was lost I would say was lost for Oracle just because of some rough edges and mostly dealing with the stuff like do other modularity systems like JBoss modules and Jigsaw will be able to work with it. I mean, there are some attempts and it should be doable, but currently I don't know if anything is working right now. Or you know, Milan? You're hiding. Okay. Yeah. How about what? Yeah, that's what this distributed SGI is for, right? So we do have some such configurations that most of our containers are deployed in I would say few instances for SLA and performance reasons, right? And we do have some. The whole architecture is pretty pluggable, so you can plug in some kind of your implementation flow balancing if you want, right? If this is what you are asking about. I mean, there are not so many, I would say, just ready-to-use stuff, but you can easily build or hook in your own code. Anybody else? Okay. So thank you very much, and have a good evening.